Alright class, our second video that goes with lecture 2. We broke this out to just do two examples to practice both unit conversions and stoichiometry. And so we'll start here with a slide example 2. How much carbon is in 1 milligram per liter of glucose? One thing to note there, you're given 1 milligram per liter. That is a concentration equivalent to parts per million. Okay, so 1 milligram per liter. Or 0.001 grams per liter. So I've already gone ahead and done the conversion from milligrams to grams for you. The way that we can convert between a molecule and an individual constituent within that molecule, this is called stoichiometry. We are going to use the molecular mass and think about how many carbons are there per molecule of C6H12O6. And so this may look a little bit familiar to you from chemistry, but we'll go through it as a quick reminder. One of the things that we can do with the periodic table is look at the atomic masses that are provided. Those are the average mass for an atom of different elements, for a mole of atoms of different elements, I should say. And so, for example, when we look at carbon, the average mass for a mole of carbon atoms is 12.011 grams. Why not exactly 12? This takes into account the different isotopes that occur in nature. So, for glucose, we've got 6 carbons weighing in at 12 grams per mole each. We've got 12 hydrogens weighing in at about 1 gram per mole each, and 6 oxygens weighing in at about 16 grams per mole each. So when we total that up, 1 mole of glucose weighs about 180 grams. So we can go ahead and use that as a conversion factor. Now we want to go from glucose itself to moles of carbon within it. And so 1 mole of glucose contains 6 moles of carbon. And you can see that because in the molecular notation you've got a C with a subscript of a 6. So it's a 6-to-1 ratio, 6 carbons to 1 glucose. We can then convert those moles of carbon back into grams of carbon and convert those grams of carbon into milligrams of carbon. Now one thing you can see that I've done here is with the different colored lines, I've gone through and crossed out units to make sure that the only thing we have left on the top is milligrams of carbon and on the bottom is liters. And so when I complete this calculation, I get about 0.4 milligrams of carbon per liter if you start with 1 milligram of glucose per liter. Hopefully this example is making sense to folks. And we're going to do one more example taking advantage of the nitrification reaction. And so this is going to exercise both the concepts that we've already looked at and help us think about chemical reactions and how one thing being consumed can teach us about something else that's associated. And so in the process of nitrification, if 12 milligrams per liter of oxygen is consumed, how much NH4 was nitrified? And so our goal here is going to be to get to milligrams per liter of NH4. So we'll start with 12 milligrams of oxygen per liter, and just like on the previous slide, we can convert that into grams of oxygen. We can use that molar mass of 16 grams of oxygen per 1 mole to convert into moles of O2. Now one thing to notice here, why is that 32 in the denominator? It's O2. So there are 2 oxygens present, 2 times 16 is 32. And so that's from the previous example. And now we're going to use this balanced, key here is that it's balanced chemical equation or chemical reaction to convert from oxygen to NH4. And so you can see that there are 2 moles of oxygen per 1 mole of NH4. Again, use the molar masses and convert back to milligrams instead of grams. We can go through and cross out all of our units to make sure that things are working correctly. And I end up with 3.375 milligrams per liter being consumed. So if we had the ability to monitor oxygen concentrations and we knew how much oxygen was consumed, we could use that information to learn something about how much nitrogen had been nitrified. One thing to note here, common, particularly in environmental engineering applications, and specifically common with nitrogen, where it can take a number of different species, Rather than discussing nitrogen in terms of ammonia, nitrate, nitrite, ammonium, all the different forms that it could be, we report it as N equivalent. And so sometimes you'll see nitrogen as N, nitrate as N, for example. And so the idea here would be to get to the same place you did above, moles of NH4, but then instead of getting to milligrams of ammonium per liter, getting to milligrams of N per liter. Not bad, we've done that on the previous slide, we can do it again. So we'll simply use this 1-to-1 molar ratio that you see in the bottom left. 1 mole of ammonium contains 1 mole of N, and we can finish out the rest of our conversion there. So that could be reported as 2.625 milligrams of ammonium as N per liter. And so the idea there is that you're reporting only the mass that's associated with N, not the entire molecule. Example 1, a bit out of order, but for you to practice your own unit conversions, go ahead and try converting 45 miles per hour into meters per second. You can email me for the answer to this, or you can Google the answer yourself. Thanks, class.